In this session, we will discuss a problem that is for calculating the state transition matrix. So, here we are adopting a method for calculating the state transmission matrix. State transition matrix, that means we are using Laplace transform method for calculating the state transmission method. So, for two cases we are discussing, that is in the case of homogeneous equation and in the case of non-homogeneous equation, we know that state transition matrix is e raised to at. So, here some of the equations relating to this, that is in the case of homogeneous state equation, this state equations will be equal to x dot of t, that is equal to a into x of t. This is the state equation for a homogeneous case, that means input equal to 0. So, in this case, the solution of this equation is in the form x of t equal to e raised to at into x of 0, where e raised to at is called state transition matrix. So, we have to calculate this matrix. So, in order to calculate this, we are using this formula. See, here x of t can be written as L inverse of phi of s into x of 0. That means e of at is equal to L inverse of phi of s. We know that e raised to at is also represented by phi of t. So, phi of s is the S transformation or Laplace transform of phi of t. So, inverse of that phi of s will give state transition matrix. So, phi of s we can calculate by using this relation, that is Si minus A all inverse. What is S? It is S domain variable S. I is unity matrix and A is the system matrix. So, you will be given the system matrix in the question. So, by using this relation, you can find phi of s. How can you find the inverse? The inverse of a matrix will be equal to 1 by determinant of that matrix into transpose of the cofactor matrix. Okay. So, that we will see how can we find this phi of s. Then the inverse Laplace transform of this phi of s will give you the state transition matrix. In the case of non-homogeneous case, the state equation will be x dot into ax plus bu. Here the system matrix is A, and we will find the solution as x of t will be equal to phi of t into x of 0 plus L inverse into phi of s into b into u of s. Here the state transition matrix is phi of t. The equation is same, that is phi of t is obtained by inverse Laplace transform of phi of s, that is obtained from this, that is L inverse of Si minus A all inverse. Let us do a problem. Consider the matrix A, which is a system matrix. Calculate the state transition matrix of this A. That is A is 0, 1, minus 2, minus 3. We know that this is a system matrix and state transition matrix is e raised to at. So, state transition matrix is given by e raised to at, that is obtained by phi of t. Phi of t will be equal to L inverse of phi of s. Phi of s is Si minus A all inverse. So, first of all, we want to find out Si minus A inverse. For that, we want to create Si minus A matrix. Si minus A means S into I is here. This is a 2 by 2 matrix. So, unity matrix is 1, 0, 0, 1 minus A is this one, that is 0, 1, minus 2, minus 3. So, that will be equal to, by taking the calculations, you will get S minus 1, 2, S plus 3. So, this is Si minus A. So, you will get Si minus A. Next, you want to find out Si minus A inverse. Okay. So, to find Si minus A inverse is equal to, it has an equation, that is transpose of the cofactor matrix of Si minus A divided by determinant of Si minus A. That is Si minus A inverse. That is the equation. So, this will give you phi of S. So, to find the transition matrix, you have to take the inverse of this phi of s. Okay. So, let us do each and every calculation. First, you will calculate the determinant of Si minus A. So, determinant of Si minus A is represented by delta, that is equal to determinant of Si minus A. Si minus A we have calculated its value as S minus 1, 2, S plus 3. So, determinant of that matrix will be S minus 1, 2, S plus 3, that is cross multiplying this. So, you will get the value S plus 2 into S plus 1. Okay. So, now you got the denominator term. Next, you want to find out the numerator term, that is cofactor of Si minus A all transpose. Okay. So, first of all, you want to find the cofactor matrix of Si minus A. Now, you have the matrix Si minus A. This is the matrix S minus 1, 2, S plus 3. So, you have, in order to find the cofactor matrix, you have to find the cofactor element for every matrix. Okay, so what is the cofactor element of this matrix? So for the S, it is S plus 3 because we are eliminating this. In the case of S, we are eliminating the row and column of that element. Okay, so here we are eliminating this row and this column, so you will get S plus 3 is the element. So the corresponding to S, the cofactor element is S plus 3. Similarly, in the case of minus 1, you will eliminate this column and this row, so you will get 2. But here 2 is not enough because you have to put the sign. In the case of this is 1 1 element, this is 1 2 element. In the case of odd element, that is 1 2 means it is an odd number. So in the case of odd element, you have to put a negative sign. So here you will get minus 2. Instead of minus 1, you will get the cofactor element as minus 2. Next, in the case of we are considering this element 2. So we will eliminate this column and this row. So you will get minus 1. But you have to see the sign here. This one is a S21 element. So 21 means it is an odd number. So instead of minus 1, you have to put plus 1. Okay, so this is the next entry. And in the case of S plus 3, you have to eliminate this row and this column. So you will get S alone. Here the element is S22. So you will get S alone. Okay, so this is the cofactor matrix corresponding to Si minus A. So the transpose of this cofactor matrix is obtained by interchanging the rows and columns. So you will get S plus 3 minus 2, that is this row comes to the place of this column and this row comes to the place of this column. Okay, so 1 S. Okay, this is the cofactor of Si minus A all transpose matrix. So you can write phi of S will be equal to, you can substitute for this. Okay, so you will get a determinant of Si minus A is S plus 2 into S plus 1. So that is written here. The numerator side, this is transpose of cofactor of Si, that is S plus 3, 1, minus 2 and S. Okay, so you can find, now you got the value of phi of S. Next what you want to find is, you want to find out e raised to at. What is e raised to at? E raised to at is phi of t. How will you get phi of t? Phi of t is obtained from inverse of phi of S. Okay, so you can write phi of S because here this quantity is multiplied for each term inside the matrix. So you will get S plus 3 by S plus 1 into S plus 2. Similarly, all other terms will be multiplied by this term. So you will get the matrix like this. To find the inverse of that phi of S, you can see here that you have to go for partial fraction expansion method. Here at the denominator side there are two terms. So this can be split as a1 by S plus 1 plus b1 by S plus 2. Similarly, this can also be split by partial fraction expansion method. So you will get this, that is a1 by S plus 1 plus b1 by S plus 2. Similarly, here a2, here b2. So you have to find out a1 value, b1 value, a2 value, b2 value. Here is the calculation side. So if you are taking this equation, so this will be equal to what is this one, S plus 3 by this one. So that is given here. S plus 3 by S plus 1 into S plus 2 equal to this term. How will you find a1? a1 will be equal to this term into denominator of this S plus 1. So at S is equal to minus 1. Okay, so that is given here. So S plus 1 terms will be cancelled out. So you will get S plus 3 by S plus 2 and you will substitute S is equal to minus 1. So you get a1 equal to 2. Similarly, b1 can be find out by how can you find out b1? This term into this denominator S plus 2 at S is equal to minus 2. So you will get B. Here also next term is this one. This will be equal to what is this one, right? So you can find A2 and B2. That is simple partial fraction expansion method. So you will get A2, B2 like that. Similarly, this term is equal to A3, B3. This will be equal to this one. Okay, minus 2 by this one. So you can expand A3, B3. So you will get values like this. So you got different values. So phi of S matrix will become like this. Okay. So phi of t is obtained by inverse of phi of S. So how can you calculate inverse of phi of S? See, this is you should know the Laplace transform. See, this is like 1 by S plus A form. So its inverse Laplace transform is e raised to minus at. So 2 is a constant. So you can take 2 into e raised to 1 by S plus 1 equal to e raised to minus t. And here also you can write minus 1 into e. What is the form of inverse Laplace transform of 1 by S plus 2? this is e raised to minus 2t, and here inverse Laplace transform is e raised to minus t, here e raised to minus 2t, here e raised to minus t, e raised to minus 2t. So the constant will be multiplied in every term, so you will get the form like this. So this is the state transition matrix. So here you need to know only one equation, that is phi of t equal to L inverse of Si minus A all inverse. A will be given in the question, so you can proceed in this manner. So you will get the value of state transition matrix. Okay. Next is another example. Here a linear time invariant system is characterized by the homogeneous state equation like this. Compute the solution of the homogeneous equation assuming the initial state vector x0 equal to 1 into 0. Here this is the homogeneous equation. What is x dot will be equal to a into x0. So x0 is what is a into x, and here initial condition x0 equal to 1, 0 is given. So you want to find out what solution of the homogeneous equation. So you want to find out x of t, solution is x of t. So in the case of homogeneous equation, solution will be equal to, we have an equation e raised to minus atc, solution will be equal to x of t equal to e raised to at into x0. x0 is given in the question. You want to find out e raised to at. So e raised to at means state transition matrix. Here a is given. You can find e raised to at. So for that, to finding e raised to at, we know that we are taking the matrix Si minus A inverse matrix. Okay. So we know that e raised to at is equal to phi of t, that is equal to L inverse of phi of s, that will be equal to L inverse of Si minus A all inverse. So we need this quantity, then only we will get e raised to at. So first of all we have to calculate Si minus A. What is A? A is 1, 0, 1, 1. Okay. A is given here. Then we can find Si minus A. So Si minus A will be this quantity. That is simple calculation. Here I is a 2 by 2 matrix, which is a unit matrix. So to find the inverse, we need determinant of Si minus A, and also we need transpose of the cofactor matrix of Si minus A. Okay. So we want to find out first of all the determinant of Si minus A, that is the determinant of this matrix. So that will be S minus 1 all square. Similarly, Si minus A all inverse will be obtained by the transpose of the cofactor matrix. So here the transpose of the cofactor matrix is S minus 1, 0, 1, S minus 1. So the calculation is discussed in the previous case. So you can proceed in that manner. So you will get this quantity Si minus A all inverse. Okay. So you can substitute, finally you will get e raised to at here, and you can substitute for e raised to at and x0. So you will get the solution like this. Okay. If you have any doubt, you can ask me, and this is a sample problem. Similar types of problems have been asked in the university examination questions. If you have any doubt, you can ask me. Thank you.